So we have many different types of sampling. We have what we call convenience sampling, simple random sampling, systematic sampling, stratified sampling, and clustered sampling. Some of these methods are better than others. Some of these methods are better in certain situations than others. So let's take a look at the first one, convenience sampling. This is the easiest type of sampling method. Unfortunately, it's also the weakest type of sampling method. Now it's easy because, as the name says, it's very convenient. This is the type of sampling where you want to ask a couple survey questions, you go out and stand on a street corner, and the first 50 people that walk up to you, you ask them the questions, and then that's it. Convenient. It's whoever you can get to be in your sample. You ask mom, you ask dad, you ask your brother, you ask your sister, you ask your kids, you ask the neighbors, and so on. You get the most convenient sample that you can. Now, that's also the worst kind of sampling. Why? Because we're going to have a lot of problems with that, as you may begin to imagine. It's probably not going to be very representative of your population. You're just getting who's available to you. You're not getting a true representation of who you might want to represent in the population. So you have to be very careful with convenience sampling. And we're going to talk about these on the next slide. What are the problems that can come up? You're going to get something called bias. You might get something called undercoverage, and so on. And we'll discuss what those are, but there are problems with convenience sampling. The best thing about it, again, it's easy. Now, the absolute best type of sample, the one that we typically want to shoot for, is the simple random sample, the SRS. This one is a very special kind of sample. So what this is akin to is if you took everybody that you are interested in the population, you put all their names on a piece of paper, you tossed them all into a giant hat, and then you went into the hat and you grabbed 50 names out. That's a simple random sample. Everybody who you're interested in has just as likely a chance as anyone else of being pulled in your sample. So every possible sample that you could get is equally likely. That's the key in simple random sampling. Every possible sample is equally likely. So every person has the same chance of being pulled into a sample, and every sample has the same chance of being pulled out. So for example, if you've got 5 people, their names in a hat, okay? Person 1 and person 2 and person 3 and person 4 and person 5, they all have the same chance of being picked out of the hat. Okay? If you're talking about taking 3 people in that sample, you could just as easily pick out of the hat person 1, 2, and 3, or you could pick out person 1, 3, and 5, or 1, 2, and 4, and so on. That's a simple random sample. That's the best kind of sampling because due to the fact that it's random and everyone has an equal chance, you should avoid bias in that sample. You shouldn't have things where you pull out all women, for example, in a population that's 50% men, 50% women. It could happen, but it's not likely to happen. Okay, the next type of sample is a systematic sample. So in a systematic sample, this is a little bit different. These will work fairly well, but it's a little bit different from a simple random sample. A simple random sample, remember, everybody is equally likely to be picked. Every sample is equally likely to be picked. Systematic samples are those types of things where you pick every 10th person, or you pick every 25th person, or something like that. These are used a lot of times in like grocery stores or supermarkets when every 10th person who walks through the door, they ask them to take a sample about their shopping habits or something like that. These samples will work pretty well, but they're not simple random samples because if you're going with every 10th person, the 9th person has 0 chance of being picked, the 11th person has 0 chance of being picked. Not every person is equally likely to be selected, and not every sample is equally likely to be selected then. So while these will work pretty good, they're much better than convenience samples, they are not simple random samples. The next type two types of samples here, stratified and clustered. These are going to be very similar to each other. They're just going to be a little bit different in logistics, in the way we think about how we set things up before we actually do the sample. These both involve simple random samples, though. We just do them in a different way. So for example, with a simple random sample of the entire U.S. population, we throw everybody's name into a hat and we grab out 50 people, 50 names. That may not be what we want to achieve. Because if you think about it, the U.S. population is more densely packed in certain areas, urban areas. Over on the East Coast, we have much more densely packed populations than over on the West Coast or in the Midwest, where you see like sparsely populated areas and things like that. So maybe instead we want to actually pull people, like 50 people from the East, 50 people from the West, 50 people from the South, something like that. So we have even representation of each area. To do that, we might want to use a stratified or a clustered sample. Now, there's very subtle differences between these. When you're talking about something like the U.S. population, and you're breaking that up into different areas, that's what we call clustering, because the groups of people are naturally broken up. The North, the South, the West, and so on. Maybe different countries. Think about countries in the world. The United States, Canada, Mexico. They're broken up already by geographical boundaries or something. They're naturally clustered together. So what we do with that is we identify our clusters. Let's go with the country example. The United States, Canada, Mexico. We'll identify each one of those countries as their own little cluster. And then we'll go in and pull a simple random sample from each cluster. And we'll put them all together for our big sample. That way we're assured of having 50 people from Canada, 50 people from the United States, and 50 people from Mexico in our sample. Now we do a similar type of thing with the stratified sample. The difference here is, instead of having that natural breakup, like a region or a country or something like that, we select the strata. Okay, we select the grouping. So for example, you might break this up into something like age group, 18 to 24, 25 to 34, 35 and over. That's a strata or a group that you have selected. Now obviously there's natural breaks in age there, because no one's going to fit into two different groups, or you're not going to have any question about where they go. But you've selected them. They haven't self-selected. They haven't selected an area or a group because of where they live, or because of what country they live in, or something like that. You've selected the strata. That's the only difference. Once you have the strata, or the groupings, then you go into each group and you pull your simple random sample and you put them all together for your overall sample. So stratified and clustered, very similar. There's only a subtle difference in the fact that in stratified you're picking the grouping, and in clustered the grouping is sort of determined by some other factor like geographical location or something like that. Now, as I mentioned on the last slide, we can have some problems with sampling. We can have some things come up that make it difficult for us to use our sample to accurately represent the population. One of these things is bias. Bias means that our sample does not look like our population. So, what does that come down to? Well, let's say we have a population where we've got 60% women, 40% males. Now, it's okay if we take a sample of 100 people if we don't get exactly 60 females and 40 males. We're not going to get things exact. This is a random process. We might have something like 57 and 43. Or we might have 61 and 39, or something like that. That's okay. But if we used a particular sampling method where, like convenience sampling or something like this, where when we looked at our sample, we had 99 men and 1 woman, we're in trouble. Okay, we have some serious concerns with this sample. It's not very representative of the population because the population has a majority of women in it, and our sample has a majority of men. So we should be a little bit concerned, and we should be a little bit careful when we're using that sample because it doesn't look like it's representative. It's very biased towards males. And we have to go back to our sampling method and see, is there something that we've done here to inflict that bias? Is there a reason that we got all males? Did we go to a sporting event or something where there is mostly males attending and we only found that one female there? What happened? How did we sample and come up with this? Was this just by random chance, or did we do something wrong? So you have to be very careful that you avoid bias. Bias is a very bad thing to have because you can't, in a biased sample, draw any inference about the population from it. Another problem that we can get with sampling is called non-response. Non-response is a very serious error too. This happens when you send surveys out, maybe you mail them out to people's mailboxes, and only that handful of people answer you. Most people look at your survey, they think it's junk mail, they throw it away, they don't have time to do it, they forget to do it, whatever. They don't do it. They don't respond to you. Okay? That's very serious, and a lot of times we'll have a very high level of non-response. So how you figure this out is you look at the number of surveys you sent out. Maybe you sent out 1,000 surveys and you only got 300 back. You have a 70% non-response rate. So you take 700, the number that you didn't get back, divided by your total number that you sent out to get your response rate, non-response rate. It's very serious if you have a very low non-response rate. There's a couple of things that could be happening here. First of all, typically people that feel very strongly on the issue, one way or another, are the ones that respond. The people that don't really know, or they're not really sure, or they don't have a really strong opinion, they're not going to answer you. They don't really care one way or another. It doesn't affect them. They've not thought about it. They don't want to think about it. Whichever way it is, they didn't respond for a reason, and the people who did, they responded for a reason. That makes them different. The people who did not respond are different from the people who did respond, probably because they're not strongly opinionated or are strongly opinionated. Either way, there's a major difference between the groups, and you should take that into account. You should also always publish your non-response rate. If you send it out, even if it's high, you should always tell people, look, I got a 70% non-response rate. Most people will not publish this. That's not a good sign. That usually means that they're hiding something. Like, we sent out 1,000 surveys and only 12 people answered us, and now they're going to try to base all of their inferences on just these 12 people. It's not going to work. They don't want to tell you that, though, because they're trying to make a point, or they're trying to write an article or something like that. But you should always publish the non-response rate. Typically people will not do it, and it's a very serious situation when you don't have it published, or when it's very low and you're trying to publish results. It gives a little bit less credibility to your data, but it's important information. Now the other problem that you can come up with is called undercoverage. Now what's undercoverage? Undercoverage means that you don't hit everybody in the population because you couldn't find them, or you didn't know they were out there, or something like that. That happens a lot, especially when you're dealing with a very large population. So think of dealing with the population of the United States. There are remote areas even within the United States where we don't have good census data. So we may underrepresent people from those areas because we simply don't know they exist. We don't know that they're there. We had no way of contacting them. So you can get undercoverage in almost any type of sample. Even if you're careful and you do a simple random sample, you still can come up with some undercoverage simply because records aren't up to date, you didn't know people existed, you couldn't get in contact with certain people because they lived in a remote region, something like that. So undercoverage is another problem. It typically exists in many of the samples. It's not as serious an error as bias or non-response. Those ones are the very serious ones. Undercoverage is serious, but it happens so often that we're used to dealing with it. And in general, if someone's in a very remote region, our study may not even really apply to them very well, so we can get around the undercoverage problem.